Hello students, you are welcome to STA 131 class. This is module 2 unit 1, and the title of this unit is frequency distribution. In this unit, students will learn about frequency distribution of categorical, grouped and ungrouped data, grouped class interval, tally, frequency, relative frequency, as well as cumulative frequency. Quickly, we want to look at a definition of terms. The first one is what I call raw data. Data collected in original form. While the next one is frequency. Frequency is the number of times a certain value or class of values occur. The next one is frequency distribution. The organization of raw data in table form with classes and frequencies. Categorical frequency distribution. A frequency distribution in which the data is only numerical or ordinal. That is what we refer to as categorical data frequency distribution. So now we want to look at ungrouped frequency distribution. A frequency distribution of numerical data when we are dealing with the raw data that is not grouped. That is what we talk of ungrouped frequency distribution. We also have group frequency distribution. A frequency distribution where several numbers are grouped into one class. Then class limit. When we talk of class limit, separate one class in a group frequency distribution from another. The class limit separates one class in a group of frequency of distribution from another. The limit could actually appear in the data and have gaps between the upper limit and one class and the lower limit of the next class. So we have class boundaries. So class boundaries separate one class in a group frequency distribution from another. We separate one class in a group frequency distribution from another. The boundaries have one more decimal place than the raw data and therefore do not appear in the data. There is no gap between the upper boundary of one class and the lower boundary of the other of the next class. The lower class boundary is found by subtracting 0.5 units from the lower class limit, and the upper class boundary is found by adding 0.5 units to the upper class limit. Difference between the upper and the lower class boundary of any class. The class width, that is the class width is the difference between the upper and the lower boundary of any class. The class width is also the difference between the lower limit of two consecutive classes or the upper limit of two consecutive classes. Class mark, which we also refer to as the midpoints or class average. The number in the middle of the class. It is found by adding the upper and the lower limit and then divided by 2. It can also be found by adding the upper and the lower boundary and dividing it, the result, by 2. Cumulative frequency. Cumulative frequency, the number of values less than the upper class boundary for the current class. This is a running total of the frequency. We shall demonstrate this. The next one is the relative frequency. This one is more or less a proportion for each group or for each class. The frequency divided by the total frequency. This gives the percentage of values falling in that particular class. Cumulative relative frequency or relative cumulative frequency. Running total to the relative frequencies or the running or the cumulative frequency divided by the total frequency. Guidelines for creating classes. Step 1. The number of class should be between 5 and 20 classes. 2. Step 2. The class length or width should be an odd number. Step 3. The classes must not overlap each other. That is, it must be mutually exclusive. Step 4. The classes must cover all data entries. It must be also inclusive or exclusive. Step 5. The classes must be in continuous form. There should be no gap in a frequency distribution. Step 6. The class must be equal in width, and the exception here is the first or the last. The first can be less or equal to, while the last one will be greater or equal to the last class there. Now, the procedure in creating groups frequency distribution. The first step, you have to find the largest and the smallest observation, that is the largest and the smallest value. The next thing, you compute the range. The range is just the maximum minus the minimum number. The next step, you select the number of classes targeted. This is normally put between 5 and 20. Then the next thing is to obtain the class width by dividing the range obtained in 2 by the number of classes in 3 and rounding up. There are 2 things to be done carefully here. You must round up, not off. Normally 3.2 will be round to be 3, but in rounding up it becomes 4. If the range divided by the number of classes give an integer value, no remainder, then you can either add 1 to the number of classes or add 1 to the number of width. The last thing, you pick a suitable starting point less than or equal to the minimum value you must be able to cover. So the number, the class width times the number of classes value, you need to cover one more value than the range. So to find the upper limit of the first class, subtract 1 from the lower limit of the second class. So the boundary, to find the class boundary by subtracting 0.5 unit from the lowest limit and 0.5 from the upper limit. Then the tally, take the tally of the data. So then you find the frequency. From the tally you find your frequency. So the cumulative frequency will then follow. Then if necessary, find the relative frequency and that of cumulative. As illustration, for categorical data, you have to consider the following block group of 25 participants in a training course at Michael Imodo Training Institute. These are the block group A, B, B, A, B, O, and so on. So for this data, we have to construct a frequency distribution table and obtain the relative as well as the cumulative frequency. Now let's look at the solution. So from this table, you can see the group A, B, O, and AB. For A, we have 9 of them. You can see the tally. The first one, this is 4. Then we use 1 to cross it. That is complete 5. This is 4. And make 9. The second one, AB, is 7. O, 3. And the last one is 6. So the relative frequency, as I've said before, is more or less a proportion. So you say take the frequency over the whole total. The whole total, we are told that we have 25 participants. 9 over 25. This one will be 7 over 25. This one will be 3 over 25. While the last one will be 6 over 25. So the cumulative, you take the first one, which is 9. You add it to the next frequency, which is 7. You add 16 to the next frequency, which is 3. 19. 19 to the last one will give us 25. So this is the last one is just the proportion, just repetition of a relative frequency. So So another, then for ungroup data, a man, this is an example just to illustrate the ungroup data. A man kept on counting of the number of GSM text messages he received each day over a period of 100 consecutive days. The raw data is as follows: 22200, that is, in a day he received, the first day he received 2, second day 2, following day, then there was a day he received nothing. So the highest there is 5. That is, the one particular day he received 5, and so on. You have to present the observation in frequency distribution table and also indicate the relative and as well as the cumulative frequency. So now let's look at the solution for this particular table. You can see it. These are the number of tests received per day. The 0, 1, 2, 3, 4, 5. The highest is 5. So for the frequency is 0. That is, in 45 days he received nothing out of the 100 days. For one day, for 30 days he received 1 text message. That is, for 30 days he received 1. For 70 days he received 2. For 4 days he received 3. For 3 days he received 4. For 1 day he received 5. So we can as well look at the relative frequency. As I've explained before, relative frequency we just say 45 upon 100, 30 upon 100, 17 upon 100, 4 upon 100, 3 upon 100, and the last one upon 100. While the cumulative, as I've said, take the first one 45 plus 30 will give us 75 to plus 17, 92 plus 4, 96 plus 3, 99 plus 1 will give us 100, and the last one is just the proportion. So this is the next one, that is for grouped data. This is a good example. 80 randomly selected light bulb were tested to determine their lifetimes in hour. This frequency distribution was obtained. You have 55, 54, 55, and so on to the last one, which is 75. You have to present this in frequency distribution table. Also indicate on the same table the relative frequency as well as the cumulative frequency. You know, the something is in hour. That means each of these bulb, they spend the first one 53 hours, 54 hours. Now let's look at the frequency table, the group frequency table. You can see it. You know, I use, for this time around, I make use of the class boundary. I can as well make use of the class limit, but I use class boundary to make it easier for us. So 52 to 55, then 52.5 to 63.5. Then the next one we start with 63.5 to 74.5. The next one 74.5 to 85.5. The next one 85.5, and so on. And these are the tally, these are the frequencies for each of them. Then the relative, as I've said before, just each of this frequency over the overall total. So the cumulative, you start with the first one 6 plus the next 12, 80 plus the next 25, and so on to the until you get to the last one. So student, we have come to the end of this particular unit. In our next episode, we shall look at the graphical representation of data. Make sure you go through your courseware and make sure you also look at your tutor mark assessment questions. Thank you. See you in the next episode. Thank you.